Craig, how are you?
Good. How are you, Nick?
Excellent. I'm like so good. A little bit kind of rushed, today. But I'm so looking forward to like this chat. I've been thinking about it, throughout the day. So, um, so how you doing, by the way?
Good. We just released Hypershield limited availability, and so things are things are picking up steam finally.
Awesome. Yeah. Well, we're going to talk about that, in a few minutes. So let me start off with making sure everybody knows you, not only your role at Cisco now, but also a little bit about your history, and kind of like what brought you to this moment of being on a Built for Trust podcast.
Yeah. So I started my career in the Army, which is completely outside of the scope of technology. But when I got out of the Army, I got into programming, starting in video game programming, and working for an online gaming company is what introduced me to networking. From there, I ended up joining Talari Networks really early on, like employee number two.
Talari?
Yeah, it was maybe the first SD-WAN company that existed way
Yeah,
back
I
when.
remember Talari. So Talari, as I remember, was really kind of arbitraging various different wide area links based
Yep.
upon performance, right? So you would have these various different metrics. And so this was like in the days when people were starting to use, whether they were using private lines, MPLSs, or broadband connections. And so how do we best choose which one? So yeah, no, I
Yeah,
remember
I mean,
Talari.
I think
Yep.
it wasn't quite SD-WAN yet. We called it WAN virtualization back then, but it was
Yeah.
starting to bring some of those concepts into market, right?
Yeah.
And then I did a short stint, about a year at Cisco in advanced development before joining another startup, VeloCloud Networks, which
Yes. Yep.
obviously is when SD-WAN really became SD-WAN. And we took some of the ideas that we had at Talari coupled with some of the improvements that had happened in the market. So one of the biggest challenges that we had at Talari was how difficult it was to configure the rules for how you would steer traffic. So I have a variety of links available to
Hmm.
me, but to understand what is the different type of traffic it is, what are the SLOs applicable to it, and then
Yeah.
people were manually writing policies like how long should I hold it before I let traffic go and things like that. And so at VeloCloud, we took the opportunity to automate all of that. So it automatically characterized the links, automatically measured all the available bandwidth, loss, latency, jitter, automatically identified the application and mapped it to an SLO, and then automated that whole thing to make it much easier to administer at scale, right? And so I
Yeah.
think everywhere you go, you should try to learn something that your
Mm.
current product isn't solving,
Yeah.
and either bring it to that product or bring it to the next place you go.
Yeah.
And through 10 years, I was with VeloCloud. We were acquired by VMware. So I
Yeah.
was the chief architect, then I was the CTO, then I was the general manager for the last year and a half.
Yeah.
One of the challenges that we had throughout was that upgrading embedded devices is really difficult, right?
Mm.
And so when I came to Cisco, I think that was sort of the core of what I wanted to come solve. I wanted to figure out a way to bring SaaS-like agility to
Mm.
embedded devices. And
Yeah.
so that was sort of the
Mm.
genesis of what became what we're going to talk about today.
Yeah. Okay. Awesome. Well, that's a really good trajectory. Military service. Tulare. Kind of a little bit of a stint, at Cisco, and then into VeloCloud. So another great startup that got acquired into VMware. So you were in VMware when Martin was in VMware, right? So there was a little overlap in there when they also had acquired Nasira.
So I came in just after Martine had left.
Oh, okay. Yeah. So, okay, I was close, so
Yeah.
close around that time. Yeah.
Yep.
What's
Very
interesting
close.
about your career, it's probably true with like most folks is that, it's, if we look about the arc of the industry, it's like, in the beginning parts of your career, we were really just getting into, um, obviously the build out of the internet was already happening, and now we were kind of into like this digital optimization, phase, which was the prelude to virtualization. And now we're into a full blown AI era, you know. So, you know, um, I'm kind of thinking like this era is really it's about you know engineering miracles. I think that's really kind of not hyperbolic, to say. We're going to talk a lot about that, at the upcoming AI networking summit. But anyway, so three biggest problems, and I think you kind of set yourself up, for that. Like, if we think about, SecOps and so forth, like, what are the three biggest issues that you're seeing within kind of SecOps?
Yeah, I mean, I'm going to take a very network security centric lens to
Perfect.
this, right?
Yeah.
And I think there are three things that we found were the biggest problems when we set out to build something to solve them, right? And I mentioned one already. Upgrades are very hard.
Yeah.
Uh, Upgrades are harder the more critical the device is. So think about like perimeter firewalls in the data center, east-west microsegmentation solutions, where we can't afford downtime, where we can't afford regressions. Those are really hard, but now we've got threats being exposed at a rapidly increasing pace, right? So like if you look at the chart of Gen AI adoption and the chart of CVE discovery, they're both ramping at the same time, right? And at the same time, AI is also making it easier to exploit these things faster. Like just stock GPT-4 can exploit more than half of the critical vulnerabilities that exist, can generate successful exploit code for more than half the critical vulnerabilities that exist. So upgrades have always been hard, but now they're more important than they ever were.
Yeah.
Right. And we saw this in even in SD-WAN, because SD-WAN as an industry evolved from being this transparent overlay to being a router replacement to being a firewall replacement, which I think it is today. SD-WAN is really a feature on your firewall. Yeah. And so now that SD-WAN device being upgraded is super critical, right? And so so I think upgrades being hard is problem number one. So if we assume that the upgrade is hard and therefore we can't close the perimeter, then we need to protect the applications that are inside, and patching applications is hard would be the second big challenge that we found, right? I think Log4j taught us all this very painfully, but it's just a matter of time before we have the next thing at that scope. And as I said, with exploit times coming down, that's becoming more and more critical. And then the way that attackers get from a breached perimeter to that vulnerable workload inside your data center is by moving laterally, but microsegmentation is hard. And so if upgrades are hard and patching is hard and microsegmentation is hard, then attackers have, and they do have, a much easier path to get in to exploit us than really is good for any of us in security.
That's a nice kind of concise way, of explaining the current state of affairs. I would overlay on top of that the massive shortage of skills, skill gap, that we have. It's like, on security engineers, it's like, like worldwide, it's like, like 3 million. In the States, it's like 750,000. It's like, it's just, we're never going to close that gap. So I think all that you're talking about, like upgrading and patching, and especially the microsegmentation stuff, those are very toil oriented. They're very tedious, tasks. And then also too, on the microsegmentation stuff, it's really difficult for users as well. So the user experience, isn't great. So okay, great. So I think that's a great way to kind of like scope this. So I want to first, if it's not appropriate to kind of like dive into this topic, then let's hold off for it. But do you see AI playing a role in solving, those problems? I know that's a focus area for Hypershield, and Hypershield is an AI product, so maybe those two are kind of combined,
Yeah, I mean, definitely. And in Hypershield, AI is a part of how we solve all of those problems, right? I think when we talk about AI, oftentimes we fall into this trap of only talking about generative AI. And so know that when I say AI, I'm talking about all of the unsexy things like matrix multiplication and machine learning and all of those things, as well as generative AI. But I think it has tremendous opportunity to do that, right? Like when we first launched VeloCloud into the market, there was just a lot of pushback from network administrators saying like, my job is to configure QoS rules, and now you're telling me that it's completely automated and I don't have to do it anymore. Are you trying to automate my job away? And we said, no, like we're trying to free you up from the drudgery and let you focus on more innovative things. And you just called it out, the skill gap in security, and they're spending so much time doing these tasks that are really kind of procedural and pattern based, right?
Yeah.
If you think about when I do an upgrade, I do a pre-test against the checklist. I do the upgrade. I do a post-test against the checklist. I look at the before and after. Like that's the kind of thing that AI is really good at. Gathering a bunch of data that's labeled and then comparing two instances of it and making an intelligent assessment of whether things have changed. So, I think we have the opportunity in a way that was never before possible to automate some of these menial tasks and really free up those 3 million SecOps engineers to go do the things that they should be doing.
Yeah. Yeah, that makes perfect sense. And I think, it's like, so I was thinking SecOps, but it's also NetOps, and I think it's really maybe to be, make it simpler. It's really infrastructure operations, it's, because we're really talking about network security and networking and network security. And then also the application, gets impacted on this as well. So like, this is really kind of at the intersection between the applications and the infrastructures. It's kind of like this domain
I think those silos will collapse, right? I mean, network and security already have in a lot of ways. Like, people would have said I was a networking guy when I started my career, but SD-WAN shifted into being, like I said, a firewall feature with SSE and SASE, bringing so much network security into it. With Hypershield, we bridge application security alongside. So I think over time, especially in a Kubernetes world, we're going to start thinking of all of these as sort of one combined group.
Yeah.
And so we need products that address that need as well.
Yeah, we need products for sure. And then we also need people and organizations to get the skill sets, so yeah, no, but I am so with you. That's the beauty of, I think, what you're about to talk about with Hypershield, but also more in general with AI is that it pulls data from all over, and so like those silos are, they are a relic, and they came into being when we had kind of the breakup of the IBM mainframe into client server computing. And so the industry broke up into like security and, networking and storage and PC LANs and so forth. And that has stayed true for, except for the PC LAN piece, has stayed true for, for decades. And so this is the first time that there's a kind of technology shift that will actually cause a organizational redesign, not just within the consumer side, but also in the industry, right? Because the every IT organization is a mirror image of really how the industry is organized, right? So it's like, so both of these are kind of in play right now. But so okay, so I'm with you. So all right, so let's so either we can jump into Hypershield or we could jump into like just how AI is going to solve these three problems.
I mean, I think they're interrelated. So maybe we talk about how we're leveraging it inside Hypershield.
Okay. Let's do that. Right? Yeah.
So yeah, I mean, let's go problem by problem, and I think talk through the various challenges, starting with the upgrades, right?
Okay.
So I think at the same time that AI has come into fruition, we've also had tremendous advancements both in CPU and the power that we can get out of a stock CPU, and then our ability to write optimized software with things like DPDK and VPP to do really high performance packet forwarding, like millions of packets per core kind of thing, right? And so one of the things that I always envisioned was, you take like your most complex customers and you build a system test bed, and part of your testing process after you get through functional verification is you go through system tests and you see how will this all work together if I made, my network look like Cisco's network as much as possible, right? Because they're using a bunch of different combinations of features and products and policy sets that expose different things than we might get testing in isolation. And everyone's thought, what if like production is the greatest system test bed, right? If we could just push everything into production and find out what breaks, that would be the greatest thing ever.
It
Course,
depends on who you're talking to.
Customers may not think that, but engineers think that, right? So the kind of the idea within Hypershield was, what if instead of think of what we call a network enforcer. You can think of it like a firewall, right? For lack of a better term. So imagine inside my Cisco ASA firewall, there were actually two virtual firewalls side by side. And I could get CI/CD updates to the second firewall inside there. And the system would simply mirror traffic between the two. And then just like our human QA team has a checklist of before and after things they do to make sure that the code works properly, we generate the output labeled in such a way that we can use AI to do the comparison of before and after. So our policies matching properly. Is the system crashing? Is the system leaking memory? Is the CPU usage the way I expect? Does the number of cycles it takes to process a packet look correct to make sure that we're not indirectly affecting the throughput of the system, right? And so to be able to do this on every single node in production in a transparent way, and then if issues are found, automatically report those issues back so they can be fixed and have the fix come down through the CI/CD process. That means not only do I get a pre-verified version of the software, but I don't have to deal with the support case if it fails, right? And tracking all of that. And there's lots of other tangential benefits that come out of that.
I'm with you. I think that's that's super. We're going to summarize that in a second. CI/CD, make sure everybody knows what you're talking about.
Okay. Yep. So CI/CD, typical way we deliver SaaS software: continuous integration, continuous delivery, or continuous integration, continuous deployment, depending on who you talk to. But the idea is that when a developer writes code, it goes through an automated promotion pipeline, a series of gates with increasing scrutiny to test it in various mechanisms all the way until it goes into production. And a CI/CD pipeline usually starts with very basic tests, like do the modules work, and ends with pre-production or simulated production, something that tries to mirror as close as possible the production environment that we're going to deploy it into. And so these digital twins that are running inside our enforcement points become our simulated production environment. So for every customer, their set of policies, their set of features they have enabled, and their traffic is being tested before they ever put the code into production.
So I think this is great. Okay, so great. So the bottom line is that every one of these kind of firewalls, they kind of have two virtual, or they have basically a digital twin in it. So you have like kind of two images running side by side, and those get kind of updated. So usually it's application developers who are kind of feeding into the CI/CD pipeline. So it's like, so I would think the reporting of whether it's running or not, or issues or not, are probably going to be parsed. I would think that's a kind of something that it's what's the word I'm looking for. You can choose where you want those events to go to.
Right.
They can go to multiple places. So that can go to both the developer team. It can also go to the operations team. So you can actually make these changes, and maybe the changes are coming from the application team or they're coming from the infrastructure team. It could run in the digital twin. You can kind of see how it's going to run. You make it errors. Or other logs, events, that's on the non-production digital twin that is then reported back. Those changes get made, they get downloaded, and that could either be automated with AI or it could be manually intervene as well. And so then you get into some steady state, and then you can choose when you want to actually turn it on. Is that correct?
Right. Yep. And that can be true for both software changes, but also policy changes, right? I have to make a new set of rules, and I want to visualize what will happen in production when I roll those rules out and review that before I actually turn them on. And then because the two data planes are running in parallel, when I'm ready to do the upgrade, it's zero downtime because traffic's already traversing the new code or the new policy. We simply change the exit point from being the old quote unquote data plane to the new data plane. So pre-qualified zero downtime upgrades for whether it's policy or software changes.
How awesome is that? That's
Now
that's like
it doesn't.
that's
Like
huge.
I'm
It's
not here to
huge.
say that this is perfect, right?
Yeah, going
We
in the right
can't catch
direction.
everything that may ever go wrong, but it's
Yeah,
certainly astronomically better than what we're doing today.
that's for sure. Yeah. Okay, that's great. So like that's kind of the configuration changes. So that was one of the problems, and change. So configuration changes, updates, and so forth of existing equipment. That was one. Then the second one was around patching
Patching
applications.
applications.
Yeah, yeah,
Yeah. So here, so now we bring a couple different things together. First is eBPF, right? So if we think about bridging network domains and application domains, you talked about that earlier. We've always wanted to
yeah.
do that from a security perspective, but the challenge has always been extending the kernel to do that, right?
Hmm.
Because either recompiling the kernel, which is very prohibitive, or building a kernel module where you're risking the stability of the system. And it's cliche to talk about what happened this summer almost at this point, but like we got a big reminder of the
Yeah,
danger of touching the kernel, right?
yeah.
Um,
That's
and
really key too,
so,
because like that's on clearly has been on the mind of everyone. So like, how do we basically not do our patches on our schedule, not their schedule?
right, yep.
So it's kind of yeah. Okay, continue.
So eBPF. So for listeners who don't know what eBPF is, it's think of it like a domain-specific programming language where I can write programs that will be compiled, verified in a sandbox, and then executed as part of the kernel itself. So I'm literally writing code with a bunch of rules around it to provide safety, to extend the functionality of the kernel at runtime. And that allows me to add code to anything that's happening in the kernel, meaning a function call, a system call, a write to a disk, a read from a disk, right? All of the things that happen in a system. Maybe most interestingly for NetSec developers, that includes the system calls encrypt and decrypt, right? So without doing man in the middle now, I can see the payload of traffic. So we have this ability to observe everything that an application is doing, including its network connections, and then also modify them or block them should we need to, right? And so what we realized was we can use this to actually prevent vulnerabilities from being exploited, right? So let's take a well-known vulnerability from this year. There was a ConnectWise Screen Connect, a remote desktop protocol vulnerability, where they have a setup wizard for the first user that goes into the system, goes to setupwizard.aspx, and they set up their admin account, and then they start using the system. And if you go back to setupwizard.aspx, it says the system's already activated, you can't get in. Right? And attackers figured out that they could append an arbitrary string after setupwizard.aspx and bypass the is it already activated check and create a new admin account and take over the server. And so obviously big risk exposure, very easy to exploit. From a eBPF perspective, that's simply a matter of saying, when we see this one system call, do a regex and strip a trailing string after setupwizard.aspx. So it's very trivial to write. It's very fast to execute. And because these eBPF hooks are so precise, the odds that we break something in the application by applying this protection are very, very low, right? Because we can be very, very targeted about the kinds of things we're doing. And so we saw this opportunity to use this for a whole class of vulnerabilities. Now, the flip side is vulnerabilities are being discovered faster than ever. More than 80 new CVEs a day this year in 2024. And I mentioned that attackers are using Gen AI to write exploit code.
Right.
So AI, this is where Gen AI actually comes directly involved, where we've been working with NVIDIA to see if we can generate these eBPF policies to prevent the vulnerabilities using AI. So just like when a vulnerability is discovered, the attacker is saying, hey, AI, write code to exploit this. We're saying, hey, AI, write an eBPF program that will prevent an attacker from exploiting this.
Right.
And then we push it down everywhere automatically. So when the next log4j happens, right, Hypershield detects what's vulnerable, generates a patch or a shield, pushes it out to everything. You can, to your point, upgrade on your timeline, because now, even though you have the vulnerable version running, it can't be exploited. And then once you patch the application, we automatically pull that exploit shield out. So trying to completely automate the process. Now, of course, AI can't generate everything, certainly not yet, where we continue to manually curate these things and train the system. But Cisco's lucky enough to have the world's largest threat research group at Cisco Talos. So we've got 500 humans to back it up and make sure that's doing the right thing, and that we can fill in the gaps. And then that just becomes a feedback loop to train the system to get better and better at writing these policies itself.
Yeah, I'll tell you, what a great technical underpinning for secure by demand. So it's like you can actually now demand from not even just from your vendors, but you can kind of demand when you want to do these patches, and then also when these exploits do appear, you can now actually put shields out and patch when you're ready.
And I mean, it's not always right. It's not always vendors, right? I mean, how often are these vulnerabilities discovered in open source libraries that we rely on? And now, there's only so much pressure you can put on a volunteer to fix something on your timeline, right? So we are beholden to how fast the community moves. So this gives you that layer of protection until those patches are available and you have the ability to roll them out.
Yeah, good point. Really good point. So, going back to the NVIDIA piece, so how does that work? So is that within that kind of that group, that 500 kind of engineer group? It's like they're kind of understanding what the exploits are, and so and they have like a GPU cluster that can create these observe, create, deploy as a service.
So I would say two things we're doing right now. One is we've got humans manually writing these policies as a means of training the AI. The other thing is that NVIDIA, as part of their Morpheus AI framework, they've done some specific work around training their AI to understand CVEs and the specifics of CVEs and the underlying attack vectors associated with them.
The very specific around CVE.
Yeah, bringing those two things together, this RAG around, specifically understanding CVEs, and then the work that we're doing around manually curating a set of training data, we bring those two together to have the system start generating the policies automatically.
Okay, great. Yeah, so it's all right. That's good. So I'm sure that's a start, of the relationship, and it'll expand, over time. So that's all right. So that's great. So is that the patch, part of that, that's really, but it's really, really strong, especially, with what happened with CrowdStrike, during the summer time frame. So, within the ONU community, like all the board members, actually, we just had a meeting a couple of weeks ago, and that was the number one topic. It's like, how do we basically do patches like on our schedule, so that we can deploy the patches when we're comfortable, with them, and so they go through our internal process, and so it's great where you can actually kind of freeze it with a shield, so you don't kind of get the downside of the exploit. And then you can do whatever process you want, to feel comfortable with the patch and the update, and then go off and do that. That's a great tool. I'm sure it's going to get, warmly received, from the marketplace.
Yeah, and I mean, even though obviously the AI helps us hit the 85 a day or whatever number, but if you think about, regression and leaky vessels and some of the most critical ones. We've got shields built already for these critical ones that are coming out in the industry. So we're able to, even at human scale, stop the most critical attacks like the log4js of the world. And then AI allows us to address the long tail of other vulnerabilities.
Yeah. Awesome. Great. Okay, Greg. So we've gotten the programming change management, of installed equipment. We also got the patch management, microsegmentation.
Yeah.
So that's a big it's a big topic. I know a big pain point, in the industry, and I'm sure it's linked into zero trust. So all right. So go ahead.
Yeah. I mean, well, zero trust says the attacker's already in the network, right? So how do we stop
Yeah.
them from moving around? I think microsegmentation is an interesting one because the first two things we talked about are things that aren't really solved in the industry today, right? And so we're trying to bring a solution to market to solve a problem that exists that doesn't have a solution out there. There's nobody that's really doing real-time shielding of vulnerabilities.
Yeah.
There's obviously a lot of companies and products out there trying to solve the microsegmentation problem, including Cisco Secure Workload, a very successful leader in the Forrester Wave for segmentation solutions, right? But I think they all share some similar challenges. One is that they rely on network data, right? So we think of microsegmentation as locking down traffic between workloads or between hosts to known ports and protocols that we want to allow in a stateful fashion.
Yeah.
But attackers have realized that as well. And so most lateral movement that we see is actually masquerading inside of known ports and protocols, right? They try to make it look like RDP or SSH or something else that's allowed in the system because it's required in the system. So that's one big challenge. I think the other big challenge that we face in segmentation is that it's a point in time thing often today. So I characterize an application and then I say, okay, deny all and allow everything that I just determined was known good traffic. But then when the application developer makes a change or the system gets upgraded or something happens, the year-end report runs that didn't run while we were characterizing the application, right? The application breaks because applications aren't these static things that never change. And in fact, in the Kubernetes world, we're trying to make them move as fast as possible.
As fast, shut them down, turn them on.
And so we have this impedance mismatch between the two. So, so this is probably, one of the most simple applications of all the different pieces that we built. But really, it comes down to all of those events. So those eBPF hooks that we have, we talked about using them for enforcement in the vulnerability piece. But if you just think of them as observability hooks, when you deploy a Hypershield agent, we learn every process that's a part of your application, every file it relies on, every IPC call that happens between those processes. And so one thing is, by bringing those two worlds together, it's no longer, let's say, host A is allowed to talk to host B on TCP 3036 for MySQL, but it's the MySQL C process itself is allowed to initiate to this specific IP or host name on that port and protocol. So the PowerShell user that's trying to masquerade on port 3036, or the local user that's trying to manipulate MySQL C, we can block those IPC connections, right? So you get segmentation that's now no longer constrained by the boundaries of the network and actually brings application awareness into it. That's one. Yeah. The other thing is that when you see anomalous behavior, right? Today, if I see a new port and protocol appear coming out of an application, I don't have a lot of context for what I should do. And so microsegmentation solutions just block it, right? And this is the big problem we have. In Hypershield, we understand why that network connection came. So was there malicious things happening on the host? Was there a version change? Was there something that we've seen happen at other sites in the network at this customer? So we know that it's a trusted expected change, right? So there's a sort of a real-time risk assessment that we can bring into it and make an intelligent decision about whether to allow or deny it. That's the day zero piece that's available now. I think looking forward, what we want to do is bring code awareness into this and sort of this shift left mindset. So what if Hypershield could read the code and write segmentation rules based on the code it ran? Then when your developer makes a commit that, let's say, requires a new port and protocol to be used from your application,
Hmm.
it learns about it before it ever makes it into production. And so it's ready and waiting for the new version to arrive and that new behavior to be allowed. So it's really trying
Wow.
to make microsegmentation or segmentation broadly an active part of what's going on
Mm.
automatically, rather than something that happens as a manual point in time analysis like it does today.
Yeah, yeah, that's really interesting. So, actually, I thought you were going to talk about something a little bit different. So, and I'll get to that in a second. But I love the whole point about context. It's like, it's now, maybe this is, the era that we're living in, because like now with AI and being able to bring in all these different, data points and points of view, and being able to kind of do deep packet inspection to kind of look at the code and reconstruct how the code was written, and if that's kind of coming as a new commit, as long as that's authenticated, then that system can actually then create that segmentation, automate that segmentation if you're comfortable and you trust it, enough. Which I'm sure there'll be a process in which that occurs. So I love that. I think that's it's like how the infrastructure is getting just so much smarter in order to make it more trustworthy
Yeah.
as well. So that infrastructure is trusted by both the developers, and it's also developed. It's also trusted by the infrastructure teams, as well. So okay, I think that's really great around how you can start to kind of get at kind of automating segmentation and micro segmentation without all the toil of pre-configuring it and getting things done, well beforehand, and then also how hackers could kind of mimic kind of east-west traffic, RPC calls, and to like kind of hide behind the packets, within a data center. So I think all that's great. I thought, Craig, where you were going to go is around identity. I thought, like,
Yeah.
you were going to
I,
start,
yeah.
you were going to talk about, okay, we've had identity, and it's me, it's my machine, but now we want to have processes as part of that identity, and policy as part of that identity. And then I think once you do that, and if you can actually use AI within the control plane of a zero trust architecture, then you can have context, wide context, and then you can actually, trust, the zero trust system to actually, kind of, almost eliminate now segmentation,
Yeah.
and create these connections, these secure connections. So
Yeah.
I
I mean,
thought you were going to go there.
identity is integral into what we're doing. I kind of glossed over it as the lower level.
Hmm.
But if you think about, so what Hypershield does takes the information from these eBPF events,
Yeah.
right? Builds a graph of all of the nodes and their adjacencies that exist
Uh huh.
inside the system. And now we enrich that with data from the software bill of materials or the SBOM, so that we
Hmm.
know process names and versions and things that humans will understand.
Yeah.
But we also give an identity to both every process as well as every workload, right? The collection
Yeah.
of processes that make that up. And we define what we call an ontology, or what the industry calls an ontology, which is like uh, a dictionary naming scheme for what this graph looks like, what the labels look like. And so, from an LLM perspective, I have a graph with labels. I have an ontology that explains what all of those labels mean.
Yeah.
So now I'm able to both build this identity aware dependency graph of everything the application does, but also have an AI assistant that can explain it in human terms, because we've all
Mm.
seen these these tools that generate application dependency maps, and it's like this giant bowl of spaghetti, and it's really
Yeah.
hard to figure out what's going on in there, right?
Yeah.
Especially when we think about like 1,000 microservice, super large Kubernetes instance type applications. So absolutely, workload and process identity is core to this. We export these both as SPIFFE IDs to
Yeah.
fit into an industry standard. In fact, we would like to work with the industry to extend SPIFFE, because I think it could be better. It could be enriched more.
Yeah.
There are things that we track alongside our identity, things like the version of software, right? If I have a proprietary application and I see that the binary signature changes, that means somebody has upgraded or downgraded that binary. That tells me some really important information about whether I should expect behavior to change or not, right?
Yeah.
And so capturing all of that and being able to map not just, this is application X, but this is application X at a specific version, and this is what it looks like everywhere else it's running. Really, really helpful for characterizing what does good look like and what does anomalous look like.
Yeah, it's having kind of automating an application's dependency map. There's so many use cases for that, and so I love your use case, but there could be just so much that kind of comes from that. Just understanding end-to-end performance, doing capacity planning on that root cause, identification, and troubleshooting. It's like there's and having that so that the kind of the infrastructure operations teams can actually understand it and have it deciphered, as well. That provides maybe the AI the tools to actually understand dependencies and causalities, and to be able to kind of help in identification of root causes. That's
Yeah, I mean,
really
there's an
so
early
good to
set
hear.
of Hypershield customers who are only looking at this from an observability standpoint. And
Mm,
use cases like you talked about, use cases like compliance. How
yeah,
do I know? How do I guarantee to a compliance auditor that nobody who's not allowed to be touching that application isn't getting in? How do I
yeah,
guarantee my developer didn't add a backdoor so that
yeah,
he or she can debug later, right? So if we have this auto-generated map and we have the ability to not only generate it, but have an actual conversation with an AI assistant
yeah.
probing into it, then it
Mm.
really simplifies a lot of those workflows that we have today.
Yeah. Well, I'll tell you, it seems like you're hitting probably 80% of the issues, right? It's like there's, especially as you now bring compliance into this, like if you talk to most infrastructure teams and even like architects, their biggest issue is the toil associated with configuration change management. The whole patch management thing is now a big deal because of this, what happened during the summer. The microsegmentation piece, that's always been a toil issue. Um, and compliance is like a huge time sink, huge. So being helped to automate that, I can see that as being a huge use case, for, many in the large enterprise marketplace, as well. So, well, these were all really good. So I think that is that kind of the,
Yeah,
encompasses, Hypershield, right? So,
yeah.
yeah, so I think that was really good. So, let's think a little bit more, kind of maybe one quick thing. Manifestation of Hypershield. Which products is it in? How is it consumed from a consumer, point of view?
So Hypershield is pure software, which is
Yeah.
not always the case from Cisco.
Hmm.
So managed through Cisco Defense Orchestrator in the cloud. Um, and today it runs on our network enforcement points run as virtual machines.
Hmm.
We're going to add support for running those in DPUs as well as in next generation top of rack switches from Cisco, which will have DPUs, which will come
Yeah.
out next year. And then from a workload protection standpoint, we protect bare metal, VM, and Kubernetes-based workloads.
Hmm.
Today, only Linux is supported. So anything running Linux kernel version 4.19 or later, we're working with Microsoft to bring complete eBPF support into Windows so
Yeah.
that we can add Windows support as well for some of these real-time protections on the workload level. So from a customer standpoint, it's as simple as
Yeah.
deploying a single agent to start on whatever workload you want to monitor. And of course, we acquired Isovalent,
Yeah.
and I haven't said their name yet, even though they co-created eBPF. They created Tetragon, the eBPF runtime security and observability library we use,
Yeah.
and they created Cilium, which is an eBPF-based CNI. So actually, the goal, the long-term aspiration is if you're running Kubernetes and you're using Cilium, we don't even want users to have to install an agent. We want to make Hypershield part of the Cilium fabric. So
Hmm.
just by virtue of using Cilium, you can turn on Hypershield and get that security automatically. Because I know agent management, it's probably the biggest challenge that folks have with a solution like this.
Yeah, I'll tell you, like I think, Tom Gillis has done such a great job with some of these acquisitions. Isovalent is like huge acquisition. Obviously, Splunk, another great acquisition as well. Talk about kind of the convergence of networking and security. You know, yeah, those are good. I'm glad you mentioned Isovalent in this. Okay, so I think also maybe that kind of leads a little bit to like roadmap, and not like a Cisco technical roadmap, but more kind of industry projection. So it seems like if I take a step back from our discussion that we just had, clearly what's happening is that there's a lot more intelligence and AI that's getting pushed into the network infrastructure, right? So like, just the sheer fact of having, Hypershield running on DPUs. And like in today, you mentioned kind of top of rack switches and kind of other, switches and, within, containers. Was it within a container? So it's that, so you can kind of see, that, how it gets permeated, all throughout, the infrastructure. And there are others that are kind of doing kind of the same thing. So I think the infrastructure is getting a lot smarter, and hopefully these are kind of trust points, that help us build this trusted infrastructure. Let's think out, maybe a little bit broader though. It's like in the next 3 to 5 years, what do you think the impact will be of these kinds of projects that Cisco is doing and others that are doing, and also where you kind of see your own roadmap on how the industry may change and how we're consuming products, to build infrastructure. And I think really I mentioned this in the very, very beginning at the AI summit in New York. The first keynote is Svi Gal, and so Svi is like the CTO of Memorial Sloan Kettering, cancer research. And so Svi's built their AI infrastructure, and he's talking about, and it's in essence enabling the miracles that now, Sloan Kettering is like, the top cancer research institution on the planet,
Mm-hmm.
and so he'll talk about, how they've been able to accelerate cancer research, by like 15 years, so it's like, and he's thinking like, he told me this, and I so hope it's true. I so hope it's true. But he's basically saying, it's like, in his thick accent, it was like, Nick, you may go into a doctor's office in the future, in the not too distant future. I'm not talking 50 years. I'm not talking 15 years, like within 5 years. And he might just say, okay, I got some, bad news. I got some good news. Bad news is that you have a cancer. The good news is that, all right, here's your prescription. You take these, you take this medication, like, and within 3 months, your cancer would be gone. No chemo, no surgery, no radiation. That's So anyway, they are working on their miracles. Every industry is working on their miracles, and so how does this kind of play into that? So what's your vision over the next 3 to 5 years of where what we enable as a community for the global community, the global population?
So I think, network connectivity, network resiliency is becoming more and more important, right? We saw with the CrowdStrike incident, again, not to single out CrowdStrike, but just to illustrate how something as simple as losing Windows machines brought air travel to a halt,
Hmm.
right? We saw with Change Healthcare how a cyber attack could bring prescription drug processing to a halt for a huge amount of Americans. And so
Oh, yeah.
we are so reliant on this
Yeah.
that the impact of a cyber attack could be devastating. And at the same time, we've got attackers using AI, and we've got nation states actually going out and driving a lot of these attacks.
Hmm.
And so,
Yeah.
I think one of the things that we say about Hypershield is that we want to change security from being a place in the network we send traffic
Hmm.
to being part of the network.
I like that.
There should be no network without security directly embedded to everything that's happening everywhere. AI is what allows us to process that kind of data and telemetry at scale. And so I
Mm.
think what we will see is these techniques that we're applying to a very specific use case, really, which is applications hosted in a data center, whether it's a public cloud data center or an on-prem data center. Still, that's what Hypershield is protecting. It's that east-west perimeter inside the data center. We need to see these same techniques extend all the way to the user and the user's device so that we have this notion of real-time, reactive, AI-driven security that's stopping threats wherever they are.
Mm.
Whether it's someone stealing your credentials, using your laptop when you got up from your desk and forgot to lock the screen, whatever it may be, right? All of those things we have the ability to track. I mean, I've
Yeah.
seen research where people look at you can identify a human from another human because the rate at which I move my mouse cursor across the screen, like pixels per microsecond, is different than the rate at which you do it. But I do it the same way every
Sure.
time, right? And there's
Yeah.
a pattern of things. I go read about NFL scores every time I open my computer, right? Like we all have these things that we do
Mm.
that are very uniquely us. And so I think taking some of these things that we use to characterize what does an application look like? How does it behave? How do we make sure that this is known valid traffic and make a real-time risk-based assessment? We're going to be doing that for everything that happens on every device everywhere in the world. And that's what AI is going to allow us to do and really make network security an intrinsic real-time part of everything that we do. Sort of the vision of zero trust network access, but I think taken all the way
Yeah.
to its complete culmination.
Yeah. Well, it's kind of hard to disagree with the connectedness and the reliance upon the economy to kind of digital infrastructure that we've all built, over these last 40 years or so, maybe 30 years, and how I love the idea of embedding security into that infrastructure versus like having these different, kind of like these gravitational forces, within the network where you kind of just send all your traffic there and yes, no, it can go or can't go, it's that, that's a major component to expand the surface area, the attack area,
I
um, to
mean,
mitigate the attack area.
it's a very fragile ecosystem, right?
Yeah.
Um, the White House just put out a roadmap to enhanced internet routing security recently, which I think fits in the same bucket because, right, BGP is very
Yeah.
prone to people doing malicious things to it, and I think, you know,
I saw
our
that. Yeah.
our reliance on the internet, coupled with how secure it is today, I think we've got a lot of catching up to do to
Yeah.
really make it as robust as it should be.
Yeah. Awesome. Well, all right. So I'm going to take a, kind of a pot shot, but so that's really what we're talking about is building trusted infrastructure. That's what it's really all about. And that's the name of our podcast here. So, Greg, I think this is a great place to kind of, conclude. That was really great. I really enjoyed, chatting with you. I'm sure everybody else did as well. I just want to thank you so much for taking the time,
Yeah.
and sharing your thoughts. So thank you.
Yeah. No, thanks, Nick. It's great to be here. It's great to talk about these things and start to see some of these problems get solved with some of these new technology advancements that we have.
Yeah, for sure. Yeah. All right. Excellent. All right. Thanks everybody for listening. Greg, thank you so much again.